Hello everyone, welcome to SS Educare Teaching Learning channel. Thank you for all my subscribers. Those who still didn't subscribe but watching my videos, please subscribe and watch my videos. Your support is my strength. Let's go to our channel. Scientist of the day. This scientist was the first woman to win Nobel Prize in Physics. This scientist was also the first woman to win the Nobel Prize in Chemistry. This scientist has discovered two new radioactive elements, that is radium and polonium. Her discovery laid the foundation in discovering radioactive treatment or radioactive techniques to isolate these radioactive isotopes. This scientist led the first research project on the impact of this radiation technology or treatment on cancers. She was the first woman to discover a mobile X-ray unit. Her motivation and self-discipline allowed her to discover such great things despite facing a discrimination as a woman. Her dedication to her work and her knowledge serves an inspiration to all of us. In fact, her story is the testament for the motivation and self-discipline. Yes. The scientist for today is Marie Curie, who discovered radioactive element, that is radium and polonium. Welcome back to the channel. In my today's video, I will be continuing with different forms of energy. We have stopped with definition of energy and units of energy. In today's video, we will see types of energy and its different forms. Okay, let's go for the types of energy. Let me first tell you what is mechanical energy. What is mechanical energy? The energy possessed by a body due to its virtue of action, whether it is at rest or in the state of motion, is called as mechanical energy. Types of mechanical energy. There are two types, potential energy and kinetic energy. Let's see what is potential energy. They both are completely different. Potential energy is the energy possessed by the body which is at rest due to its change in the position, shape or size. I hope you understood the definition. When any body is at rest, the energy possessed by the body or the body showing that sort of energy to change its shape or size or its position is called as potential energy. For an example, I am throwing a ball from a certain height. That is potential energy. Or I am throwing any object from top of my house to the ground. That is also an example of potential energy. That is what is potential energy written on the board. See, potential energy, body at rest due to its position, size or shape. Example is throwing a ball from top of the building. Before going into types of potential energy, let me clearly tell you the mechanical energy is again divided into potential energy and kinetic energy. Potential energy is further divided into elastic potential energy and gravitational potential energy. Then kinetic energy is divided into three types: translational kinetic energy, vibrational kinetic energy and rotational kinetic energy. We know that all these three is related to the body and motion. Whereas gravitational energy and elastic energy is, we are like applying energy for the body which is at rest. That is your potential energy. That is what is being divided. See, potential energy and kinetic energy. The sum total of potential energy and kinetic energy gives your mechanical energy. So, the total mechanical energy is equal to potential energy and kinetic energy. Mechanical energy is divided into potential energy and kinetic energy. Potential energy is even more divided into elastic potential energy, gravitational potential energy. Whereas here, kinetic energy is again divided into translational, vibrational and rotational. Yes, I have already told you the definition of potential energy. So, we will be moving on to the first example or first type of potential energy, that is your elastic potential energy. As the name says, elastic, elasticity. What is elasticity? Let me take a rubber band. I am stretching the rubber band to a certain position to a certain distance. Take for example, rubber band is there. I am going to stretch it to a certain distance. What will happen? The original shape of the rubber band will be changed. And again I am relieving the rubber band from one hand so that the rubber band which is stretched comes back to its original shape. That is what is called as elasticity. So, initially before I am applying force on the rubber band, definitely for a rubber band to stretch I need to apply a force on it. So, when an external force, whatever force I am applying is the external force on the rubber band. So, when an external force applied by me on the rubber band stretches, isn't it? So, before that, what is the condition of the rubber band? The rubber band is at rest. When I am applying force in the form of stretching, the rubber band stretches due to the external force applied by me, and then when I am relieving from one side, the rubber band comes back to its original shape or the size. That is what is called as elasticity. So, the energy possessed by the body to change its position or shape or size is called as elastic potential energy. That is what is elastic potential energy. Potential energy due to changed size and shape of the object. Elasticity. Body regains its original shape and size after removal of external force. When external force is removed from the object, the body retains back its original shape. That is what is the wonderful feature of elasticity. On removal of this force, it retains back its original shape, which is called as elastic potential energy. We have seen elastic potential energy. Now it is gravitational potential energy. As the name says, gravitation, that is any energy possessed by the body against the force of gravity exerted by the earth. Take for example, I am taking an object or a stone which is placed on the earth. I am going to lift it up. Definitely I have to supply some sort of energy. So that energy is against the force of gravity. I am lifting the object against the force of gravity from the earth. I am lifting it up. Okay. So the distance from the earth is also increasing. That is what is distance from the earth is increasing. Distance is increasing. But the force of gravity, earth will not apply the force when the distance from the object and the earth is increasing. So the force of gravity will decrease. But potential energy will increase because there is a difference in the distance from the earth to the object moving, displaced, isn't it? That is what is told here. Amount of work done in lifting an object from down, I am lifting an object up. From the earth, I am lifting an object up to the height against the gravity. Isn't it? I am taking the object from up, I am separating the object from the earth. So that is against the force of gravity of the earth. As the distance of the object from the surface of the earth increases, as the distance increases, the force of attraction of the earth decreases. Because earth is like separated from the object, so the force of attraction will be decreasing, but the gravitational potential energy will increase. So let the body of mass, let the body and object of mass be m. From down I am displacing, I am moving it up to a certain height, let that be h. And the force of gravity exerted by the earth will be G. So what will be the work done? We know that work done is equal to force into displacement. So what is force here? M, that is your mass of an object, and G, your gravity. So mg into the object is displaced to a certain height, that is h. So work done is equal to mgh. That is what is given here. There are two cases. When a body is thrown vertically upwards, or when an object is lifted from down to upwards, the height of the body is increasing. From down it is coming up. So height of the body is increasing and potential energy will also increase. Then when a body is released down, the height of the object, the height decreases and the potential energy will also decrease. So this is two cases of gravitational potential energy. We have seen potential energy, that is elastic potential energy, and gravitational potential energy. In the first case, I am lifting an object from down to up. Always I said h1 is the height up and h2 is down. So an object is moving from h2 to h1. So it is gain in the potential energy. Isn't it? From down to up it is moving. So it is gain in the potential energy from h2 to h1. So how the gain in the potential energy is calculated? Final potential energy, that is your mgh2 height minus your initial potential energy, that is mgh1. So mgh2 minus h1. mg is taken common out. Then second case, when an object is thrown from upwards to downwards, it is losing potential energy. From up to down it is moving. So no need of any potential energy when it is falling down. That is what is happening when we come down from a mountain or stairs. We need not apply any sort of energy. It will come as such like that. But when we have to climb up, when we have to move up, we need to possess more amount of energy. So gain in the potential energy is when we are moving from down to up. Okay, and in the same case, when we are moving from top to bottom, the potential energy is lost. That is calculated as initial potential energy minus final potential energy. Gain is final potential energy minus initial potential energy. So initial potential energy is mgh1 minus final potential energy is mgh2. We have seen here h2. So mg is taken common outwards. h1 minus h2 is loss in the potential energy. Gain in the potential energy is mgh2 minus h1. This is what is potential energy. It's two types, that is elastic potential energy and gravitational potential energy. Next is kinetic energy. The dead opposite of potential energy. The energy possessed by a body when it is at rest is potential energy. Energy possessed by the body when it is moving is kinetic energy. Examples are a moving car, a moving fan, a moving grinder, a moving mixie, or a moving man, or the hands of a clock keep moving. All these are possessing kinetic energy for its motion. Next is expression for kinetic energy. What is the formula or what is the expression that denotes your kinetic energy? How to derive that expression for kinetic energy? Let's see that. Let me take a body of mass, certain mass of m, moving with a velocity v, brought to rest by applying force. That is what is definition of kinetic energy. And moving object, an energy is applied or a force is applied to stop the object or bring the object to rest is nothing but your kinetic energy. An object which is at rest, I am applying energy or the force to make the object move is potential energy. Now that kinetic energy, a body of mass m moving with a velocity v, brought to rest by applying force F. If A is the uniform retardation, because a moving object I am applying force to make it stop, that is retardation, that is opposite force, isn't it? Acceleration. So acceleration will be negative, minus A it will be. So retarding force is a moving object is made to stop, opposite force, opposing force, isn't it? So that is retarding force. That is equal to m into A. That is your first equation. Next, second equation, kinetic energy. What is kinetic energy's role in this? Kinetic energy is equal to this retarding force into how much the object is displaced. So K is equal to retarding force F into object displaced S. That is your equation 2. Next, how to calculate displacement using this S? Yes, to calculate displacement using all this, let's see, to find out how much the object has displaced, we should know its initial velocity and final velocity. So initial velocity as always is denoted by u and your initial velocity is capital V. Then final velocity, that is an object is moving, I am applying energy or opposing force in it, final velocity will be 0 and object is made to stop. So initial velocity, the object will be possessing when it is starting, that is initial velocity is V and the object is made to stop. That is your final velocity is 0. That's why. Next, acceleration is here it is retardation. Opposite force. Acceleration will be negative. Minus A. Then, from the equation, we know that from Newton's laws of motion, Newton's equations of motion, we know that when velocity is given, initial velocity, final velocity and acceleration is there, we use this equation to find out its displacement. So V square is equal to U square plus 2AS. So here I said V square, in final velocity V is 0. So it is 0 square and initial velocity U is equal to capital V. That is V square. Here A is minus A. So minus 2AS. So the 0, this 2AS is V is coming this side, 2AS kept there, V is coming to the other side of the equal to. So minus 2AS is equal to minus V square, minus minus gets cancelled. So what did I want to calculate displacement? S. So S is kept this side and remaining this 2A is taken other side. So if it is taking other side, it becomes V square by 2A. That is your equation 3. Now with this we are substituting the value of F and S, we get the final equation. We need to find out kinetic energy. Kinetic energy is equal to force into displacement. We know the displacement, we have found out it is V square by 2S. F we know it is ma. From Newton's first law of motion, F is equal to ma into S is equal to V square by 2A. A gets cancelled. So what is left here? 1 by 2, this 2 is taken this side since it is a fraction. 1 by 2 mv square is the kinetic energy expression. Expression for kinetic energy is half mv square. From this formula we can say that on doubling this velocity, velocity is already in square. So when I am doubling this velocity, kinetic energy will be increased 4 times. Because kinetic energy is directly proportional to square of velocity. So on doubling the velocity, the kinetic energy becomes 4 times. That is what is the expression for kinetic energy. That is half mv square. The last topic for the day is work energy theorem. How is work done related with energy? How do you derive this work done, or how do you relate this work done with energy? In the formula, let's see. Let a body of mass m is moving with a velocity u, that is initial velocity is always expressed as u. Constant force F is applied, it produces an acceleration when an object is moving with different velocity, isn't it? Rate of change of velocity is acceleration. When velocity is changing, the body will produce an acceleration. So it produces an acceleration and velocity increases. So from initial velocity, the object keep on, when force is applied, the object will move with increasing velocity. So final velocity will be more when compared with initial velocity when force is applied. So velocity increases from u to capital V in moving a distance or displacement s. Okay, so in such case force F is equal to mass into acceleration, we know. F is equal to ma. That is your equation 1. Next, displacement we have already calculated. Displacement S is equal to v square minus u square by 2a. We have already seen it. Next, substituting these values of F and S from equation 1 and 2, we get work done is equal to F into S, we know. Work done is calculated as F into S. What is F? ma. And what is S? V square minus u square by 2a. So cancelling these 2a's, a, what is left out? Half, this 2 is taken outside the bracket. So 1 by 2 m v square minus u square is your work done. Next, this can be taken it as v square minus u square. I am just taking it out and writing individually as half mv square minus half mu square. Multiplying this m with v square and u square, I am getting half mv square minus half mu square. That is your equation 3. So, initial kinetic energy, I am denoting it as Ki. That is your, we know that initial velocity or any initial is u only. Final is always v. So, half mu square and final kinetic energy Kf is equal to half mv square. So, from this equation, we know that what is this half mv square? Half mv square is your final kinetic energy. So that is your final kinetic energy minus initial kinetic energy is half mu square. So half mu square is nothing but Ki. That is your initial kinetic energy. So work done is equal to Kf minus Ki. So work done is equal to increase in kinetic energy. Isn't it? Always the final kinetic energy is more and initial kinetic energy is less. So what is work done? Work is done in increasing the energy when velocity is also increasing. That is what is work energy theorem. How come this both theorem, work and energy, both quantities are related? When work is said to be done, the energy is also increased in making the object move with different velocities. As velocity is increasing, the energy possessed by the body will also increase because the object is displaced. So the velocity will also be increased and energy will also be increased. So that increase in energy we call it as work done. So work done is equal to increase in the kinetic energy. So that is what is parts or kinds of energy and different forms of energy in my today's video. Hope you all understood the energy types and forms. In my next video, I will discuss how potential energy is converted to kinetic energy and different forms of energy. Energy is expressed in different forms: solar energy, wind energy, or electrical energy, translational energy. So many types of energies are there. Everything I'll be discussing with one example in my next video. So if you like my video, please don't forget to click like button and please subscribe my channel and watch my videos. Definitely your support is my strength. So keep supporting me and please watch my videos fully, don't skip in the middle. So that's all for today. I'm signing off. Thank you.